So, good morning, this is my lower face shell project, and right now I am going to explain and detail a little bit of all the components from it. Over here we can see an ultrasonic distance sensor, a micro servo. We can tell that it is a micro as it has three possible connections, two LEDs, one red and one yellow, with their respective resistors, and our main brain of the project, which is called the Arduino. We can also see that the trigger and the echo are respectively connected to the 12 and 11 pins, and the red LED is connected to the pin number 4, while the yellow one is connected to the number 2. We can also see that the orange pin of the micro servo is connected to the pin number 9, and the rest of wires are connected to the power and the ground of the system, that is powered up by these 5 volts power of the Arduino and the ground. This is our testing area. As you could see, we're going to work with three different distances: the 12-inch distance, the 24-inch distance, and a distance higher than 24 inches. We have arranged the system like this, as the distance sensor and our Arduino is set up to react specifically at these distances and below. Over here we can see our arrangement with the Arduino plate connected to the main plate, where the two LEDs, yellow and red, are connected to their respective resistances and their power to their respective pins that are deeper explained in the earlier section of the video. Over here we can also see that our servo is connected at a higher distance for us to be able to identify its movement, and we can also see that the distance sensor is placed over here, just aligned with our distance signs for a precise measurement. We are going to work with a pine cone, and let's place it on the distance higher than 24 inches. As you could see, nothing is happening, and this shows us that in first instance our model is working correctly. Now let's place it on the 24-inch distance, and just as the second as I place it, you could see that the yellow LED starts to turn on and off. As we set up the code to start making this at a 24 inches distance and below, it is working correctly. And now let's place it at the 12 inches distance. As you can see, just at the second I placed it, the red LED started turning on and off, and the yellow LED turned off totally. We could also hear that the servo started to move to a distance of 90 degrees, and if we turn it back, it is supposed to return to its initial position, as it is doing. Now you could see that the yellow LED turned on again and the red one turned off, and if we place it back to the 12-inch distance, it is going to happen again. That you just saw was a false measurement taken because I placed my hand right next to the distance sensor, so in addition to the pine cone, it also measured the distance of my hand. But as you could see, it is working properly with an activation of the servo and the red LED at a 12-inch distance and below, with just an activation of the yellow LED at a 24 inches and higher than 12 inches, and with nothing happening at a distance higher than 24 inches. And this is our coding section. First of all, I want to explain you that over here is where we set all the pins that are going to be useful for the project. As you can see, we have the pin number 12 and the number 11 connected to the ultrasonic distance sensor. as well as the number 4 and the number 2 connected respectively to the red and yellow LEDs, and finally the pin number 9 connected to the activation of the microservo, where it leads to the option of turning it to 90 degrees and turning back to 0 degrees. And first of all, we need to explain the creation of a variable, where we establish the distance variable and we set its value as the distance or the data measured by our ultrasonic distance sensor. That way we are going to be able to quantify all the information and to establish specific answers or reactions according to each value that it gives us. First of all, analyzing the red LED, we can see that we have a conditional if that it's activated if the measured distance is equal or lower than 12 and higher than 0. Why higher than 0? Because sometimes if the distance sensor isn't measuring not anything, it is going to give us false numbers, and we don't want those false numbers, as they might cause unwanted reactions from our machine, like activating the servo or the LEDs in a time where they are not supposed to do it, as we are receiving a distance of 0 that is stating us that the object is too far away, and that's why neither our LEDs or our servo is supposed to activate in that kind of situations, and that's why we established that the distance needs to be higher than 0. And if this condition is fulfilled, we can see that the pin number 4 or our red LED is set up to high. Then we wait 0.25 seconds and we set it up to low. We can see that the blinking effect from the LEDs is occasioned by the short time that they have to turn on and off, and that's why they blink. Secondly, we can also see that the yellow LED has almost the same code as the red one. The only difference is the necessary values for activating this condition. First of all, the distance needs to be higher than 12 and lower than 24, and if this scenario is fulfilled, the yellow LED is going to be activated in the same way as the red one, but never in the same time. While the yellow LED is turned off, if the distances are lower than 12 and higher than 0, the red LED is going to be turned on, and vice versa with the yellow LED. And it is the same case with our microservo. We can see that if the measured distance is lower or equal to 12 and higher than 0, the servo is going to rotate to 90 degrees, and that way we can see that this condition is exactly the same one as the proposed condition for the red LED. And at the very end, we can see that if the distance is higher than 12 inches, our microservo is going to go back to its initial position at 0 degrees. This is going to be it, and thanks for your time.